Okay, so here is practice exam 2, points back, step 1. I accidentally wrote all of this on my step 2 paper, so I just had to change that. Okay, so this is the no calculator section. So, all right, here we're doing something a little different so that you don't have to watch these videos in class. So, what I'm going to do here is I'm going to give you an example or maybe some facts or notes that will help you to correct the problem once you're in class. And then down here we've got some examples. Guys, if you got the problem wrong, but you basically like know what you're doing, you're not completely lost on it, then you should try it yourself, okay? If you do try it yourself, though, make sure that you fast forward through what I do to make sure that you got the right answer. If you don't want to do the you try, like I say, it's optional but recommended. Then you could just skip right to the we do thing. Okay, so if G, so this is a similar example to problem 1 that was on the first multiple choice section of your practice exam 2. All right, so if G of 0 equals 5, use the graph of G prime to find the minimum value of G on this interval. Okay, and then here, guys, I'm giving you like a graph like this, so you're gonna have to pause the video a lot to write things, but this is, so this shaded area is 2, this shaded area 3, this shaded area 9. All right, anytime that, okay, so let's say this, since min on closed interval need candidates test. Okay, so we need the candidates test. This is where you go like this. Oh, shoot. Okay, that's the graph of G prime. What should I do? Yeah, this is G prime. Okay, so I have to tell you that this x value is, let's say that this is 1, that x value. And let's say that this x value is 3. Okay, so 0, 1, 3, and 7, those are the x values. Okay, so what you've got to do for the candidates test is you go x, and then here will be G of x. Okay, and then up here, so here go the endpoints. So I'll have 0 and 7 there and there. And then between 0 and 7, this is where you put the critical numbers. And the critical numbers are where G prime equals 0 or is undefined. So I look at the picture and I see that G prime is 0 here and here and here. Okay, but that was an endpoint. So 1 and 3. So I'm going to get the outputs, and I just have to, figure out which one is the lowest one. And by the way, guys, when you're on your own, you could do this much faster than I'm doing. Okay. I'm treating this like carefully, almost like I would a free response problem right now. To find the right answer, I would go faster on my own. Okay, so you have to ask yourself, if you've got this, do you need a limit, a derivative, or an antiderivative? So we've got to find an expression for g of x, limit, derivative, antiderivative. Well, guys, we have the derivative graph, so that means that we need to go backwards, so the antiderivative. So you need the antiderivative with an integral formula. So let's say, so for this first one, so I'm going to have that G of 0 is equal to, you need some x value, oh, actually, they gave us that. So G of 0 is 5. So I already knew, so we're starting out at 5. That was the initial condition. Now for this one, I'm going to have G of 1 is equal to, it's going to be G of 0 plus the integral from 0 to 1, and then this will be g prime of w dw. Okay, I'm running out of room. So this is equal to, g of 0 is 5, and then this area here is actually negative 2, because it's a negative area. So it's going to be 5 minus 2, which is 3. And if this doesn't make sense, guys, pause the video and figure it out. Then this one here, I've got to go g of 3. So I'm just using the antiderivative with an integral formula. Maybe I should show it to you. It's in AP Calculus Exam Topics to look for. So this is what I'm using right here. Okay, that's what I'm using right now. So g of 3 is again same, going to be g of 0 again, which so that's, I'll just put in a 5, plus the integral from 0 to 3 this time, g prime of w dw. And this is going to be 5. And now this integral here is this area and that area together. So it's going to be negative 2 and then plus 3. So that'll be a plus 1. So that'll be 6. And then for the seventh one, 7, g of 7 equals again 5. Okay, so that's what g of 0 is. Plus the integral from 0 to 7. Okay, so this time it's negative 2 plus positive 3 and then minus 9. Okay, so that is 1 minus 9, so that's negative 8. So this here is negative 8, so 5 plus negative 8 makes negative 3. Find the minimum value of g. Okay, so this would be the answer. Okay, so right here, this is the answer. Because you look at all of those values, this is the absolute. All right, so maybe I'll write here, that's the absolute min. All right, that's the minimum value on an interval. Okay. So this next one. If g prime of x equals this, find the x values at which relative extrema occur. So if you hear about, so absolute extrema, you need the candidate's test. Relative extrema, you need a number line test, okay? And you also need to know Susan's table. So where is Susan's table? Okay, so this is in the part 1, number 4. And guys, you really need to be familiarizing yourself with everything in this packet. Okay, so we're going to need this. So I've got f prime. So I'm looking for where f prime is positive or negative, because those are going to be where f is increased. No. Yeah. Okay, so basically I'm looking for sign changes. All right, I'm looking for sign changes. And then if I go from positive to negative, that'll be, yeah, never mind. I'll get there. I'll get there when I get there. Okay, so anyway, I need the zeros of this. Okay, so the critical numbers, that's where g prime is 0 undefined, are x equals 0, x equals 3, and x equals negative 1, because that's where this is 0. So then I go g prime. I think when you do a number line test, you should write up above here what you're trying to get sign changes on. Because a lot of times people will say, well, what do I plug things back into? And you won't have to ask that question if you've written g prime up there, because the answer is whatever is here. Okay, so this is the g prime number line. So these are g prime values. So here I'll put 0, here I'll put negative 1, here I'll put 3. Okay, so I'll pick a number here, like negative 10 or something. I get negative times negative, and then this is always positive because it's squared. So a negative times a positive, so that's positive. Now I'll plug in like negative 1/2. So negative, negative, positive. So again, what? Yeah, okay, this will work, I think. Positive. Right, yeah. And I'll plug like 2 in. Positive, negative, positive. So there's a negative. And then I'll plug like 7 or something in. Positive, positive, positive. Positive. So guys, there's only 2. Okay, so we've got sign changes here and there. Okay, so this, so G prime is going from positive, so from increasing to decreasing there. And then, so increasing again there. So this would be, so increasing to decreasing, so this is a relative max, and then decreasing to increasing, relative min. Okay. Oh, this is going to be a long video. I'm sorry. Okay. Now, here I'm just going to tell you some facts that will help. So write this down for your notes for when you're redoing this. Direct substitution you can do on B through E. And that would give you, well, you could do it on all of them. So direct substitution, I think on the first one gives you 0. Direct substitution on B through E gives you 0 over 0. So you can use L'Hopital's rule. Okay, so write that down for yourself. And then here I just want us to say some things. So the derivative of f of x is just f prime of x. The derivative of f of 3, guys, f of 3 is a number. This is the derivative of a constant, so that'll just be 0. Now the derivative of this, you've got to do chain rule. Okay, and then f of x. So the derivative of this is negative 1. No. I'm sorry. That's bad. Blank. So the derivative of this is negative 1, and the derivative of this is f prime of blank, and then what goes back in here is the original. So this would be negative f prime of negative x. Okay, that's all I'm going to say about that. Now this next one. Okay, so we're going a little faster now. So just write this down. Okay, things that will help you. You need to think about no, want, when. Okay, this is a related rates problem. Okay, so this is a related rates problem. Okay, so that would be good to know too. It's a related rates problem. And in here, you can find related rates problems there. Okay, so that would also help you. So you need related rates problems. You also need to know the area of a circle is this formula and the circumference is this formula. And then here's just some notes, a little something to help you. You will need to take the derivative, implicit differentiation, by the way, on both of these equations above. And that's all I'm going to say. And that should help you. Okay, I will try to go faster. Number 5, examples that will help you with this one. Okay, so here's the example. Okay, so for this equation, find dy dx evaluated at this. Okay, so let me say this. Okay, it means dy dx evaluated at 1, 1. Okay, that's what that means. So dy dx, and then if you do a bar and then a point, it means evaluated at that point. Okay, so try it, guys. I think you could do this. Okay, so definitely you try if you think you've got this. All right, so here is the we do. So I need product rule on this one. So I go 3x squared dx y squared plus x to the third times 2y dy dx. Oh shoot, I'm running out of room. plus 5 dy dx equals 2y dy dx minus 3 dx dx. Okay, so chain rule on everything. But guys, the dx dx's, those cancel. All right, and now I'm going to switch to primes. So what you end up with here is 3x squared y squared plus 2x to the third y prime plus 5y prime equals 2y prime minus 3. Okay, I think I'm right. All right, and now if I were you, instead of solving for y prime, plug this in right now. All right, so I'm going to go like this. All right, I'm a placeholder fan. All right, but you don't have to use placeholders if you don't want. It helps me go faster. Okay, so I'm putting placeholders in for everything. Now the good news about this is that x and y are the same. So 1 is just going in for everything. 1, 1, 1, 1, 1. Right? So this is just 3 plus 2y prime plus 5y prime equals 2y prime minus 3. Okay, so I got to solve for y prime. So, I could subtract that from both sides. And then I could also subtract that from both sides. So I get 5y prime equals negative 6. So y prime equals negative 6 over 5. Okay, so I guess the moral of the story is you're going to save yourself time if you plug in the coordinates before solving for y prime. Okay, this one, just some notes. Okay, you need to know this. The natural log of x will never be equal to 0. And natural log of x equals 1. Let's solve that. Okay, so think about it this way. This is log base e of x equals 1. And then you roll the log. Okay, so you go e to the first equals x. So e to the first equals x, something like that. Okay, so e to the first equals x, then x equals e. Okay, so that's going to help you. In addition to that, use number lines and Susan's table to think about sign changes. You need an f prime number line and an f double prime number line like this. Okay, and then you got to get critical numbers and look for sign changes. Okay, 7. Here is a similar example. Okay, so this is what we wanna, okay, so we got this function. So the input variable is t. Okay, so the input goes here and up there in the upper limit of integration. This w is just a dummy variable. A dummy variable is just a placeholder. Yeah, so the w is just a placeholder. That's all that it is. The t is the input, but where the w is just a placeholder. So we're going to find g prime of e. So we've got to find the derivative of this. So I've got to do an in and out situation. If this was just a t, then we would just drop if this was just a t, we would just drop that stuff, and then it would be natural log of t. But since this is a function other than t, that is the inside function. And then the outside function, okay, the blank goes where the input goes. So the integral from 7 to blank of natural log of w dw. The derivative of this is 2t. The derivative of this stuff cancels, and you end up getting natural log of blank. Okay, whatever this upper limit is goes in for the dummy variable. And then what goes back here is what used to be in the blank to begin with. So just like that. All right, so this is g prime of t. And I need g prime of e. So that's going to be 2e times natural log of e squared. Okay, now this is something that you need to know. It's from last year. I know it was a while ago, but this rule, so this comes outside times 2 natural log of e. And natural log of e is 1. Okay, so 4e is what that derivative is. Okay, next, here's an example. We've got y equals inverse tangent of 7x. We're going to find dy dx, which is the derivative. I haven't been asking that. We need to be asking all the time, limit derivative or antiderivative. Okay, limit, derivative, antiderivative. Okay. So the answer is derivative. And you need chain rule, because it's not just an x that's inside of the tangent, it's 7x. So in and out. 7x, inverse tangent of blank. 7. This you just have to know, guys, the derivative of inverse tangent is 1 over 1 plus blank squared. Okay? And then what goes back in here is what was in there to begin with. So this is, so dy dx is 7 over 1 plus 49x squared. Okay. This one. Okay, so here's a similar example to that problem. So we're going to do the limit as x approaches 1 of this rational function. You really have two options here. You can either factor and simplify, or you can use L'Hopital's rule. So I'm going to do both ways. All right, so you could try it both ways if you want on your own, but let's do it definitely both ways. So the factor and simplify way goes like this. Okay, so the top factors like that. All right, and then this is x plus 3x minus 1. So those cancel. So what we're really dealing with is the limit as x approaches 1 of x plus 1 over x plus 3. And then you direct substitute again. Oh, by the way, you try to direct substitute and you get 0 over 0. So that's why I can't do this. And this is, all right, so there's the first way. It depends on what's faster for you. Now the second way, okay, actually let's go back up here for a second, guys. Equals 0 over 0. Okay, make sure you show that. Now this is multiple choice, so I'm not going to be like, therefore by L'Hopital's rule. If it was short answer, you'd have to, but, so this time I go the limit as x approaches 1, and then I'm just going to do the derivative of the numerator over the derivative of the denominator. So this is the limit as x approaches 1, and then this is 2x over 2x plus 2. Yes, and it works. And then you try to direct substitute again, and you get 2 over 4 equals 1/2. So whatever way is faster for you. For me, the first way is faster. Yeah, but that's just me. Okay, I do so much factoring. I do more factoring in my life than most people, you know, because it's like my job. So factoring is a fast thing for me. But if you in the moment feel a little bit rusty on it, although I think you're all very good at factoring, but if you feel a little bit rusty on it in the moment, or you just don't think of it, then L'Hopital's rule is great. And number 10, you can absolutely do this one. All right, if you didn't get it right, I'm sure it was just a little mistake. Okay, guys, I'll talk to you later.